Hi, everyone. How are you? So today we continue for next one. Okay. Last lesson we do exist existence of existence of limits, right? And then today we're gonna go for non-existence of limits. Um, See the definition when the condition is we couldn't find the value of limits or find the value of function of limit. Okay. So now see below here. From here, okay. From the question, this one, they have three conditions. Okay, three conditions. First one is f of x become infinitely large or infinitely small as approaches c from either side. This is the first one. Okay, so this one, what it means, we can see the first as, okay, see the number two first. F of x approaches L. L is the value of y, right? As x approaches c from the right, and f of x approaches m. That means have two functions now, right? From the left and from the right hand. So with m not equal to L as s approaches c from the left. And third one, f of x oscillated infinitely many times between two numbers as x approaches c from either side. Okay, now we see the first condition here. Number one, how does it look like? The function become infinitely large or infinitely small. See this one, okay? First one. See, question say if one us discuss the existence of limit 1 over x squared when x approaches 0. Okay, from this one, you can see if we plot graph, right? Everyone still remember in this function, maybe use another color, 1 over x, right? If you have like a 1 over x, 1 over x squared it is. From this, if you have function, just say, if I write down like this one, f of x equal to 1 over x. We consider by function first, 1 over x squared, okay? So can you tell me what the horizontal asymptote and vertical asymptote? Vertical asymptote, everyone still remember how to see the denominator here, right? So this, of course, x shouldn't be 0, right? So when we plot graph here, say we plot graph here, okay? When we plot graph, that means the vertical asymptote is x shouldn't be 0 or equal to 0 here. So that means this one gonna be on the x-axis here gonna be vertical asymptote. Everyone recall? So this gonna be vertical asymptote. Okay. Vertical asymptote. So then next one we know this one. How about horizontal asymptote? Is you see this one on the top one, right? This mean one like a x power 0 and this x power 2. So this degree, the higher degree and numerator less than denominators. So we have horizontal asymptote, which is y equal to 0 here. So another word is mean this one become vocal line, right? Become horizontal asymptote. We learned last year, correct? How to get horizontal and vertical asymptote. When you have this, then you can plot graph, right? Say if from the left, right? You plot from the left. If x negative 1, because this is a real number, okay? So for example, if x negative 1, so you repeat negative 1 become positive, right? So it become 1, for example, 1 right here. So you can have here. And if also 2x negative 2 like this. So you replace it, gonna be positive, always positive, right? Because power even number here. So gonna be 1/4 gonna be here less than 1. So the graph, and then it approaches from this one, it closer and closer approaches 0. So the graph gonna be go up here because this one gonna be always positive, right? So gonna go higher like this. So the graph gonna be go like this one, right? And this side just approach to x-axis, and this one approach to y-axis. And at the same time, if x become positive, like a 1 here, this is gonna be 1 here also, and so on. It 2 gonna be somewhere here. And when approach to the right hand side, right? This one gonna be same. So this graph, this right hand side graph gonna be symmetry with the left hand side. So there should be symmetry, right? Should be symmetry like this. Should be symmetry. Okay. Should be symmetry, okay, but my drawing maybe not really correct. So like this one. So same like this graph, just say that. There's symmetry. But then you see when we take the limit, when we take the limit of this one, limit f of x, when x approaches 0, right? This one equal to limit of 1/x² when x approaches 0. So both sides from the left approach to here and from the right approach to the y-axis. So that means the approach to positive infinity, correct? So the answer in this case, you must like positive plus sign also. But in this case, they will say does not exist. At this moment, you can answer this one. This limit does not exist. But actually, they can say in this case is equal to positive infinities also. With this, you're gonna learn limits involving the infinity later in detail, later part. So at this moment, you can say it doesn't exist, but actually can answer that equal to plus infinity, positive infinity. Positive infinity, okay? Okay, so this is the idea for the example number 1 here. Example 4 here, okay? So now, and this is, you can say non-exist of limit temporarily. So you can say it doesn't exist. Okay, now we go next example for example 5. See the limit of this one, limit of function absolute x over x when x approaches 0, if it exists, whether or not, correct? So now we can see, I write down here, f of x we consider by this one function for absolute x over x here. So we can see, we can everyone still remember the value of, the definition of absolute values. If absolute x here, they have 2 cases, right? Will equal to x when x is what? Greater than or equal to 0, and equal to negative x when x less than 0, correct? Now we can apply from this one. Say if x equal to absolute x over x, so they have become what? When this one, when x greater than or equal to 0. So this one gonna be become plus x over x, and this equal to 1. But when x, I write down here. When x less than 0, okay, f of x will equal to from if when this one, right, f of x gonna be equal to this one. If they're less than, then come out become negative x over x. That equal to -1. Okay, so we can conclusion if x greater than equal to 0, limit f of x when x approaches 0, okay, will equal to 1. This case is under here, okay, this is the first case and the second case. Then this one gonna be, you take limit, then take limit f of x when x approaches 0, okay, this one equal to -1. So in this case, you can see when the limit approach from the left, here, right? From the left hand side, this one become 1. And then just say that because it's a greater than, so it should be right hand side, sorry. Approach from the right hand, this one equal to 1. And when x approaches 0 from the left, will equal to -1. So we can see this from the left and from the right. These two cases are not equal. That's not equal. Okay, so this one can say so that this function does do not approach the same real number or the same answer. Just say this is a value of y. This also a value of y. Okay, so that's not equal. So that we can say this. We can say this limit, this answer. Oh, sorry, it should be down here. This one, limit of this one does not exist because of the value of limit when x approaches 0 from the left does not equal to when x approaches 0 from the right. Okay, so it doesn't exist. So this for this one, number 2 here. Okay, this case number 2 is this one, and number 1 here is this case. This one, okay. Oh, this one. Now we go number 3. Okay, go the case 3 here. Function oscillated infinitely many times between. Okay, so the first one, number 3. I use skin color. Number 3 here. Okay, so we go the next page. What the meaning of the oscillate infinitely many times between two numbers as x approaches c from either side. Okay, see this example. Let me delete this old one. Oh, something wrong. Let me delete the old one, okay? Now this the third example, which is talk about oscillation function here. Oscillation function or oscillating functions. So see, find limit psi pi over x when x approaches 0, if it exists. Okay. So here you can right now the example they load it down. They just start from if x is a 1/2 Okay, keep approach closer to 0, approach closer to 0, right? Like up to from 1/2 to 1/8. So from this right hand side here. That means if you replace, like start from 1/2, right? Replace x here, you will have somewhere here, and on the right hand side, the graph will move closer between 1 and -1. That's the maximum and minimum point for the psi function, correct? And if from the left hand side, they will oscillate like this. So you can see this when they oscillate from the right hand side and so on, right? This one, the graph gonna be like this, keep up and down, very close or closer. X is closer to x equal to 0, and at the same time from the left, they will move at the same thing. So at this case, you see, they will move between 1 and -1. As x approaches 0, the function take every value between -1 and 1 infinitely, many times, from the right and from the left, like this, up and down. Okay, so in this one, we will conclusion that this function does not approach one particular real number, because they keep doing both sides. So both side up to here and right hand side up to here, left side left. So we don't know where the function will stop, but only closer x equal to 0, but never touch x equal to 0. Okay, so only approach closer from the left and from the right. So we conclusion this function does not exist. Okay, this one, if you have the TI graphic calculator, the Texas instrument, you can try this one. They will show you it is same. Okay, so we say this function doesn't exist. Okay, so I think this is the example for non-exist of limits. Okay, then I think it's enough for you to practice some questions. So next, I will give you some question, the exercise to practice. You can check in the GC, okay? And maybe I will give you some example for work, maybe 1 or 2 questions from the exercise, and then you know how to start. Okay, so see you next class, okay? For the next example, but at least you try to do your practice question first, okay? Okay, bye-bye. Thank you.